Welcome to Maths with EJD. We continue with the partial differential equations playlist, having considered an introduction and method of characteristics for solving uh, partial differential equations, especially first order partial differential equations. So in this lesson, in this video, we'll be talking about quasi-linear and fully nonlinear PDEs. Let's see what these are about. So by way of introduction, okay, PDEs can be classified into two main categories based on the nature of their non-linearities. Okay, so in that case, we can then have them to be either quasi-linear. Quasi is like almost linear or behaving like linear, quasi-linear, and fully non-linear. So quasi-linear is like almost non-linear. Then that's why we can contrast that with fully nonlinear PDEs. So understanding these two types is crucial because they arise in various physical, engineering, and mathematical problems. Okay, so let's go straight to talk about um guess I want to switch now. Let's have this here. And then this can be this. Okay. Okay, maybe not that. Now let's say this. Okay. Now quasi linear partial differential equations. So a quasi-linear partial differential equation is a type of nonlinear PDE where the highest order derivative, the highest order, so we've talked about order before now, the highest order derivatives appear linearly. So the highest order derivative appear linearly, and the other lower orders are not necessarily like that. Okay, so we say this that while lower order derivatives and the function itself and the function itself may contain nonlinear terms. Okay, the equation is considered quasi-linear because the highest derivatives are linear. The highest derivatives are linear. Okay, so that's why it's quasi-linear. So let's talk about the general form of quasi-linear equations. So a general quasi-linear PDE is f of x u u sub x u sub y. That's partial. It's like partial u partial y partial u partial x partial u partial y all the way down to partial u partial the last variable, and that is equal to 0, where u of x of y and all that is the unknown function, says the unknown function, and ux, uy, like that, etc. are first the first order partial derivatives. Okay, so in a more explicit form, quasi-linear PDEs can be written as a of x comma y comma u partial squared u partial x squared plus b of x comma y comma u partial squared u partial y squared plus all the rest is equal to 0. Okay, like that. So here, the highest order, the highest order, the highest order derivatives, like uxx. Of course, by the way, I've already told you this is the same as uxx, and this is uyy. Okay, so those kind of derivatives are actually linear. So they are linear, while the coefficients, while the coefficients and lower order derivatives may be nonlinear, may be nonlinear. So that's to say that for the highest order derivatives, the power has to be 1, and they are not multiplied by the dependent variable in any way. Okay. So, but then if you go lower, if you go to lower derivatives, maybe the function itself and everything, those can be nonlinear. All right. So having talked about this, let's move on to fully nonlinear PDEs. We are talking about quasi-linear and fully nonlinear PDEs. So you can see that uh, quasi-linear PDEs are not fully linear. I mean, are not fully nonlinear like that, right? They are not. They are almost nonlinear, but they are not quite. Okay. So fully nonlinear PDEs now. So a fully nonlinear PDE, it means it's totally nonlinear. A fully nonlinear PDE is a PDE where the highest order, derivatives appear in a nonlinear manner. Unlike the quasi one where the highest order derivative is nonlinear. Okay, so these equations are typically harder to solve than quasi-linear equations. because of the complex relationships, because of the complex relationships between the dependent variable and its derivatives. Okay, so let's look at the general form for that. General form of fully nonlinear partial differential equations. So here we say that a fully nonlinear PDE can be written as f of x, u, ux, uy, uxx, uxy, uyy equals 0. So in this equation, the highest order derivatives like uxx, uxy, and uyy they all appear in a nonlinear form, in a non-linear form, meaning that their relationships, meaning that their relationship with the function u, with the function u is not linear. Okay, so let's move on as we talk about some key differences. We'll just compare them. So key differences between quasi-linear and fully nonlinear PDEs. Okay, so let's start with the feature. We have the feature. How do I do this? Okay, let's talk about the feature, and then we have the quasi-linear PDEs, and then we have the fully nonlinear PDEs. So we take the first feature, which is highest order derivative. So highest order derivatives. So for highest order derivatives, for quasi-linear, the highest order derivative is linear in highest order derivatives, like I said already. Here for fully nonlinear, so it's nonlinear. They are nonlinear in highest order derivatives and highest order derivatives. That goes. And then we have the next one. Examples of this, examples. So example would be first order and second order PDEs. So we have first order and second order PDEs are some examples for quasi-linear PDEs. And then we have for fully nonlinear, they have to be second order or higher order. So the minimum order for a fully nonlinear PDE is second order. So second order or higher order PDEs. And then we move on to the last thing. Oh, okay, not the last, not quite the last, right? Um, yeah, second to the last. So we have what you can call the solving methods. So which method do you use in solving quasi-linear PDE? So you have methods like method of characteristics. We've used that in the previous video. So we can use method of characteristics here. Then for PDEs, for the fully nonlinear PDEs, so often require numerical methods, often require numerical methods, viscosity solutions, viscosity solutions, or even specialized techniques. Specialized techniques. Okay. So lastly, we talk about the complexity. Of course, obviously, we have an idea of that. So quasi-linear PDEs are relatively simpler. They're relatively simpler than fully nonlinear PDEs. On the other hand, of course, it goes without saying that fully nonlinear PDEs are more complex. They're more complex and typically harder to solve. And typically harder to solve. And that is why we need numerical methods or specialized techniques to take care of them. Okay. So with that done, can we see some examples? We won't have worked examples here because in the next video I'll be talking about worked examples. Um, so this comes now, and then we can go on to this. So let's talk about examples of both quasi-linear and fully nonlinear. So let's take example one. Example one, focusing on quasi-linear PDE, quasi-linear PDE. So here we have something like partial u, partial x, plus u, partial y equals 0. Obviously, this is non-linear, but we still have this one. This one is free, you know. So we can take this as quasi-linear. So this is a first order. It's a first order quasi-linear PDE because the highest derivative, well, I think it will make more sense if I have partial squared u, partial x squared, actually. This is better so that because partial u, partial x, and partial u, partial y are of the same order, right? So it's better. So this is more reliable as an example. Even if the equation doesn't make sense, in real terms, but just to give an example. So this is a first order quasi-linear PDE because because the highest derivative partial squared u, partial x squared is linear. Okay, it doesn't have u multiplying it, and the degree is 1, so it's linear. But the term, u partial y is non-linear. Okay, this is a very perfect example of a quasi-linear stuff. So the highest order derivative is linear, but you have lower terms as non-linear. And that's why it's quasi-linear. It looks like linear, but it's not quite linear. So example 2, we have example for fully non-linear PDE. Fully non-linear PDE. And that is partial squared u, partial x squared, all squared, plus partial squared u, partial y squared, all squared equals 1. So you see here that the highest derivatives are nonlinear because they are of degree 2. Okay, so this is a second order, third degree, a second order, second degree partial differential equation. Okay, so this is a second order. This is a second order, fully nonlinear PDE because the second derivatives, uxx and uyy appear in a nonlinear form. In case you're forgotten, this is uxx and this is uyy, another way of writing them. Okay, so we can go for the summary now. Is it necessary? Okay, yeah, I think it's fine to do this. So summary. First of all, quasi-linear PDEs have linear highest order. They have linear highest order derivatives, but can contain nonlinear lower order terms. Nonlinear lower order terms. Okay. Number 2, fully nonlinear PDEs. Fully nonlinear PDEs involve nonlinear terms. In the highest order derivatives. And lastly, which I think is important, understanding these classifications is essential for selecting appropriate solution methods in different applications. So if you know the nature of the problem you're solving, and you can know the right method to apply in solving it. And that's why generally in partial differential equations, before you start solving, it's better you classify, even for regular ones like the elliptic, hyperbolic, and parabolic partial differential equations. It's important to know their nature because they will tell you the kind of outcome the result will look like. Right. So with this, we come to the end of this video, talking about quasi-linear and fully non-linear partial differential equations. In the next video, we'll be talking about how to solve these problems, how to solve these two types of PDEs. So let me know in the comment section how helpful these videos are for you. And if you need me to teach a topic or solve a problem, please go ahead and let me know. I may be able to find time to do that along the line. And of course, if you have subscribed to the channel, thank you so much. If you haven't subscribed, of course, it would be good if you do that right now. And everybody, don't forget to hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.